Hi, I'm Ryan Baker, and this is Big Day in Education. Today, we'll be discussing text mining. Text mining is it's a big area. It's related to discourse processing, computational linguistics, natural language processing. It's hard. It's very different from the types of interaction data and course data that I've been discussing throughout the rest of the class. And I'll be frank, this lecture is only going to skim the very surface of this huge topic. There are entire MOOCs on this. Key thing about text mining, different stuff works. Stuff that works poorly in interaction data works great in text mining. Stuff like support vector machines. Don't see it very much in interaction data, great in text mining. Stuff that works great in interaction data, less relevant in text mining. Bayesian knowledge tracing, IRT. There's a lot of interesting attributes of textual data that explain this. First of all, really high dimensionality. There's a lot of words in a corpus of data. You can represent that as like columns. There's tons of columns, very sparse. There's multiple levels of analysis that look very different from each other, from individual phonemes and graphemes to entire books. Analyses are often conducted at the level of whether individual words are seen. And a popular algorithm for this is latent semantic analysis, or LSA, where we represent utterances or paragraphs as rows, and each column is a word that can be present or absent, 1 or 0. And then we conduct singular value decomposition, a matrix factorization algorithm conceptually similar to factor analysis, and for that matter, non-negative matrix factorization from last week, to find structure. LSA doesn't look at the syntax of sentences, it just looks at what words are present. Sometimes it's called bag of words. It does consider co-occurrences of words across larger corpuses. But alternatively, analysis is conducted using things like pairs of words in order, called bigrams, or triplets of words in order, called trigrams. For example, in the sentence, colorless green ideas sleep furiously, the bigrams there are colorless green, green ideas, ideas sleep, and sleep furiously. The trigrams, colorless green ideas sleep, ideas sleep furiously. There's a lot of tools for conducting text mining. Lightside is a toolkit that supports turning utterances into unigrams, bigrams, and trigrams, as well as more powerful feature extraction methods, and then running the dataset through a range of machine learning algorithms. Semantic tagging. Another approach to doing text mining is to reduce specific words instead to semantic categories, such as sports, business, time, things like that prior to analysis. So instead of thinking about Quidditch or basketball, we're thinking of sports. This allows easier categorization of types of utterances that's less dependent on the presence of specific words. One good tool for this is Luke. Another one is W-matrix. Luke versus W-matrix? Well, there's a lot of virtues to either, but largely who uses them is that Luke is used by North Americans and W-matrix is used by people in Great Britain. Another type of tool can provide coherence metrics, which is a modern updated version of reading level metrics such as Flesch-Kincaid. How hard is a text to read? This is analyzed by tools like Cometrics or its more recent competitor Taco, which really makes me realize how close it is to lunchtime right now. Another thing people analyze is lexical sophistication. How complex or advanced a text and the words in it are. One of the popular tools for this is Tails. This includes a lot of other measures as well, including measures of cohesion. Another feature that can be modeled in text mining is syntactic complexity. How complex or advanced the grammatical features in a text are. One popular tool for this is the L2 Syntactic Complexity Analyzer. Sentiment analysis. Assessing emotion or attitude, typically in terms of just positive-negative valence. So unlike a lot of the work in affect detection, which we talked about a few weeks ago, sentiment analysis typically isn't trying to figure out, is the student bored? Are they frustrated? But just, do they like this? Do they dislike this? And it originally came from, to a large degree, product reviews, where people were trying to figure out, do people like this widget? There are many tools for sentiment analysis. It's probably the most popular problem in text mining. One of them is the aforementioned Luke. In education, see Seance. There's a lot of uses of text mining in education. Among them include the analysis of sentiment and emotions within learner utterances, studying participation within online discussion forums, studying pair collaboration online, studying learner expertise in Think Aloud protocol data, and relating academic performance to students' activity in blogging and microblogging activities, and many, many, many more. Text mining is a big area. So that's it for text mining for today. In the next lecture, we'll discuss hidden Markov models. Thank you very much.